Hello students, and welcome to a how-to video on balancing chemical equations. Today we're going to be combining hydrogen and oxygen to form water. Okay, we can see that here with hydrogen and oxygen forming water, but what we're missing is the coefficients. Now you may notice hydrogen and oxygen, they're in pairs. Now the reason we put them in pairs is because they're considered diatomic. And if we look over here at our periodic table, diatomic elements include fluorine, chlorine, bromine, and iodine. Oh, going off page here. So these four, and then we have nitrogen, oxygen, and fluorine. So it's kind of this corner of atoms will always be diatomic when they're by themselves. They're very reactive. They want to interact with all the things around them because they're wanting that extra electron, and they have a very strong urge to take electrons and react. And they're most stable when they're combined. And all of these atoms here will form single bonds with another of their kind. Oxygen will form a double and nitrogen will form a triple bond. And if you write it out with Lewis-Strauss structures, you'll know what I'm talking about. And the other exception to this rule in the corner is hydrogen. Hydrogen's also part of being the diatomic crew. Okay, so these corner atoms here are going to be our diatomic atoms. Now hydrogen and oxygen are by themselves, so they're going to be diatomic. And when we're looking at balancing equations, what we're going to do is kind of piece together what we're missing. So we have two hydrogens here and two hydrogens here, okay? And on this side we have two oxygens, and on this side we only have one oxygen. There's a miss, okay? One oxygen is now missing from the equation with the way it stands. And based on the law of conservation of mass, we've talked about in class and in the previous videos, that can't happen. Atoms need to be shifted around. And what we need to do is figure out how to balance it. And an easy way to start doing this is let's start out by balancing out what we know. So we have oxygen and oxygen. We need to have two oxygens to balance out. Oh, keep up this paper. We need two oxygens to equal this side. We have two oxygens over here. But now our hydrogens are off, and we have 2 times 2 is 4 hydrogens. So to make this balance, we need to add 2 hydrogen molecules on this side. So now it's balanced, okay, and this would just be 1, okay? And if we were to write this down below, we would just not include the 1, okay, because it's given. We basically assume that that's what's going to happen, okay? So we have 4 hydrogens, 2 oxygens, and 2 oxygens, and this is balanced. And let me pull the book out here, and let's show this out. So we put it on page. Let me get to this page. Right here. So this is it in model form. So we have a diatomic hydrogen, diatomic oxygen reacting to form water. But if you notice, there's an oxygen missing. So in order to balance this out, we have to add a second pair, and it's going to form 1 molecule of water. And this is a happy equation. It has the equal number of the different types of atoms on both sides. Okay? All right, I think that's it for this video. Thanks for watching.